Hi, so this is my Formula One race strategy predictor. So I'll just give a quick overview of how this thing works. On the left, you can see there's race parameters. So let's say if I want to predict the Monza Formula One race for 2025, I would select the year to 2025 and then I'll change the name to Monza and I'll select the session. So there are multiple practice sessions before the main race, and I would select the practice session 2, which is FP2, because that's one of the longest sessions, and we have a lot more data to make a good prediction. Okay, so for the total laps, I will select 53 because that's the total number of laps for Monza. The pit stops time will be 22 seconds because that's the average pit stops time for the Formula One race. And for the base lap time is it's basically the quickest lap completed by a driver. So from the practice session 2 data, we know Max completed the quickest race and that was in 79.5 seconds. So, and the fuel effect is basically the the amount of time that we gained each lap because of the fuel loss. So since our car is getting lighter, our car basically gets a bit faster. So we try to add that time back to our calculation. Whereas the tire wears out and we lose time. So both balances out in our calculation. In that way, we can predict the optimum strategy. Okay, so next, let's click here to analyze race and predict strategy. And we're getting some data. Okay, so let's see what we get here. So that's the tire degradation model. So for the race, all the drivers have used the medium and hard compounds. And this is the degradation rate for both, which is quite similar, but the hard compound had the highest degradation compared to medium. And which means that the hard compound will wear out quicker than medium. And this is the comparison of top strategies. So we have all the possible strategies and the total time that would take to finish the race if they opt for the respective strategy. And this is for one stop and two stop both. So yeah, and we can see here that the optimal strategy found by our model was the hard and then medium, and then for the final pit stop going for medium. And we do that on around lap 15 and 34, and that would make the predicted total race time at 1 hour 11 minute 49 seconds, which is quite good because in actual race day, Max Verstappen won the race and completed the entire race in 1 hour 13 minute and most likely 50 seconds. But yeah, that's quite a good prediction by that is done by our model. Next, we have the driver performance deep dive, and I would like to compare here, for example, Verstappen's race time to, let's choose Gasly because he has used a medium compound tire as well. Yeah, so let's give it a bit of time and it should be ready. Oops, I'll just select it to medium. Yep. Yeah, so both Verstappen and Gasly used the medium compound, and we can see the degradation rate for both the drivers. So the x-axis shows the tire life, and the y-axis shows the fuel corrected lap time. So this is a linear regression model. Um, so the line tells us how the relationship between both the tire life and the fuel corrected lap time is. So as we can see that as the tire life increases, um, the lap time also increases because obviously the medium tire is wearing out and the time is going to increase. So we can see that Verstappen is maintaining his medium tire better than Gasly because Gasly has his line on top of Verstappen, and which shows that Gasly is losing more time compared to Verstappen. And yeah, in this way we can compare other drivers as well, selecting the respective tire compound. So for example, we choose Bortoleto, so we can see um, Bortoleto was managing his tire better than Gasly for almost 12 laps, and after 12 laps I think he was having a bit of hard time. So yeah, and this is how you can have a deep dive on the tire management of each drivers on by selecting the tire compound. Yep, that's it from the prediction of this race. Yeah, you can play around and select the year and race name, and you can see how what's the optimal strategy will be. Thank you.